Okay, so as in the last video we have solved multiple choice questions from 1 to 10 from the Nust past paper book. In today's video we are gonna solve the MCQs from 11th to 20. Alright, so let's check our 11th MCQ, what they are asking us in this MCQs. Alright, in a discharge tube at room pressure there is a maximum discharge, minimum discharge, no discharge, moderate discharge. This we have already discussed when we were discussing about what discharge tube experiments, when we were basically discovering the electron and the proton in the discharge tube. All right, we were performing discharge tube experiment. So there we have already discussed at room temperature there was no discharge, right? So our correct option here is what? It is no discharge, right? Wait, there would be no discharge. Okay, so 12th MCQ, which of the following quantum numbers are for P subshell? We know that for S subshell there is 0 azimuthal quantum number, for P subshell there is 1 azimuthal quantum number, and magnetic quantum number will be from plus L to the minus L, which means from plus 1 to the minus 1, which includes plus 1, 0 and 1. So our L is 1 and M will be plus 1, 0, minus 1, which means our correct option is the first one. L is equal to 1, M is equal to plus 1, 0 and minus 1. Alright, then in the 13th MCQ, what they are asking us in this MCQ is which quantum number decides energy of the orbital. That again we have discussed in very detail. Principal quantum number is there for determining the energy of the subshells, right? In which what subshell the electron will be going in the first. So that is decided by principal quantum number. Then the 14th MCQ, D subshell has how many orbitals? We know that S subshell has 1 orbital, P subshell has 3 orbital, and D subshell has 5 orbitals. Then F subshell will be having 7 orbitals. So they are asking us in the D subshell has 5 orbitals. 5 orbitals. Okay, so our 15th MCQ is when alpha particles are bombarded on beryllium, dash is formed. And this reaction we have already discussed when we were discussing about neutron, how neutron was discovered, right? Neutron was of course discovered by James Chadwick when he was performing an experiment with the alpha particle. What he did, he bombarded alpha particle on the beryllium plate. Thus carbon was discovered. With that, neutron was produced with atomic mass 1 but 0 charge, right? So our correct option here would be of course the carbon. Carbon is the correct answer. So 16, bracket series of hydrogen atom in which of the following regions of electromagnetic? We know that Lyman series fall in the region of ultraviolet, Balmer series in the visible region, and then a Paston series near infrared region, and Beckett series in the infrared region. So our correct option is infrared. Then 17, if an electron jumps from 4th orbit to the 1st orbit, which of the following series it will show? Electron from anywhere goes to the 1st orbit. We know that this series is known as Lyman series, right? 18th MCQ, which number of transition possible for an electron in the 6th shell? We have basically learned the formula for this, and the formula was this was n minus 1, then n minus 1 plus 1 divided by 2. Thus this plus 1 cancels with this minus 1. So the formula which we get here is n into n minus 1 upon 2. So we can put here this in the formula upon 2. So our n is here, you know what, 6, right? So 6 into 6 minus 1, 6 into 6 minus 1 is 5 upon 2, 6 into 5 is 30, and 30 upon 2 is 15, is equal to 15. Alright, so our correct option here would be 15. Now in the 19, what are the values for the orbital quantum number L and magnetic quantum number M? For P subshell, again, for S subshell we have azimuthal quantum number 0. For P we have azimuthal quantum number 1, which means L is equal to 1, and M values starts from positive L to the negative L, which means M would be equal to plus 1, 0, minus 1. So here our correct option is this first one. L is equal to 1, M is equal to 0, plus 1 and minus 1. The last MCQ of the Nust past paper guidebook: if an electron jumps from 6th orbit to the 2nd orbit, then decreases in the radius. Of course, this same formula here we're gonna use, right? New radius minus original radius upon original radius into 100%. So now this is your task to do. I'm telling here the answer, which is basically 90%. The same formula will be used here. So in today's video we have completed the 20 MCQs from Nust past paper guidebook. In the next video we are gonna solve MCQs of the chapter 5 atomic structure from Ecat book. This was all for today.